Uh, okay. Hi everyone. Sorry I'm late. I think it was just really just big internet difficulty this morning. Like my whole system kind of I mean, we're changing over our providers, so like um I think that's probably why, but it should be my internet should be stable for the rest of this class. But so I think we can get started. We're on unit 3, universal gravitational law. So basically, today what we'll cover is the last part of unit 3, and then I think I will assign an assignment at the end of today's class, but it'll be based on like the questions we go over in today's class, so it won't be too challenging. Um, just some housekeeping stuff. I think there's the report cards or midterm uh report cards. Um, they should be you guys should have received your results. If not, then just tell me and I'll tell Dr. Hassine and then you'll sort that out. In terms of timeline, we're November 11th today, so I plan to finish unit 3 by the end of today and tomorrow's class. So November 18th will be unit 3 test. And then yeah. So okay. All right. So right. So we left off on the universal gravitational law. So um let's just remember a few formulas. So there is the okay. Okay. I will. Okay. Okay. So right. So we right. So I think if you haven't received your midterm grades yet, I think I do think it's still processed through OUAC or Ontario University Application Center. So you don't need to worry about that. I think Dr. Steen definitely will take care of that. I think the actual if you're talking about the actual like if you want the like PDF version or copy or physical copy, I think it'll take some time, but I think it's submitted already. It should be submitted. Um, okay. So right. So we had this formula called FG, which is basically like um so right. So it's a force of gravity, and then there's this cool little symbol here, which is it basically says it's proportional. So meaning that the amount of mass in the first planet times the amount of mass in like the second planet, where you can think of these two things as like objects, and then they're basically separated because um in space everything's kind of circular. So it's kind of so the reason why we divide it by r squared is because you measure the distance between the centers of like the objects, but in this case all the objects in space are circular. So that's what we use for radius. Uh, so this formula was important because when it boils down to universal gravitational uh, questions. So the first example is this one. So So we have this question here. It says Earth's gravitational pull on a spacecraft some distance away is 1.2 times 10 to the this notation's kind of weird. Times 10 to the 2 newtons in magnitude. So the question asks, what will the magnitude of the force of gravity be on the second spacecraft with 1.5 times the mass of the first spacecraft at a distance from Earth's center that is 0.5 times as great? So it's a lot of words, but they're just basically saying if you have two objects that are some distance away, what is that force of attraction between the two objects? So this question, 1 second, let me just fix up the notation here. Um, yeah. Okay, so all you need to do to solve this question is reference the formula here. I'll just label it as number 1 because I think there'll be variations of this formula, but essentially, if you can just remember this, you should be fine. For the final exam, there's no formula sheet, so you got to kind of remember what you got to remember. But essentially, and I think it's pretty good practice for even like because everyone here is going to university, so it's probably good practice to not rely on a formula sheet. Mainly because it's in university they don't give you formula sheets, especially in like first year classes they don't. So it's just better to prepare you now for that. And these formulas aren't that hard, really. Like if you think about it, like we always have two objects, and then so just label it as you can even label it as O1 or O2. It doesn't matter. But if you just divide it by like the distance between those two objects, which is the radius, then you're good. You're good. So this question, oh, 1 second, I think there's a problem here. So, okay, so this is supposed to be r squared, not r to the, so r squared, okay. So this question, let's label out, so remember what we established is called the RAS method. So essentially we got to state what we're given. So in this case, we're given force number 1 to be 1.2 times 10 to the 2 newtons. And then the mass of the second object is going to be 1.5. And then r squared r2. Okay. So the question, okay, so we got to find what the force of gravity is on the spacecraft, right? So in this case, you know, running out of space. So oh, that's fine. Okay, so we have 2 is equal to 0.45 R1, and then the force of the second spacecraft on the object number 1 is what we're trying to look for. But this will be in the required section. So this is all we're given right now. Just these 4 pieces of information, and then we're asked to solve for F2. So let's just write it all out. I think it's better because I don't think the word text is really getting point home here. So we have F2, which is the force of object number 2 over force of object number one. So when you see this, what you're seeing is a ratio. So you're seeing, okay, what we're establishing is there's two objects. We're interested in what force number two is operating on force number one. So using our formula on the first page over here, this one, we're the force of gravity. That's all it is. It's I didn't put FG, but that's all we're trying to see, right? The force of gravity from object number two exerting on object number one. We know the universal gravitational constant, big G, times m1, which is the mass of object number one, times it by the mass of object number two, divided by their distances or centers of mass squared, which is the radius. So we'll denote this by like R2 squared. Okay, when you have this, then it's just essentially, you just plug in the numbers and then you can solve it. So we can rearrange, okay, so I guess you do have to do some algebra. So you got to get FG2 by itself. So when you do that, you just multiply both sides by FG1 because the reciprocal cancels the denominator. So you have FG 2, which is the force of gravity from object number two. And whatever you do to the left-hand side, you have to do to the right-hand side. So I'll just multiply it. I'll show you guys. So you have FG1 and this will cancel with this. So then you're just left with FG2, but then you have to multiply FG1 also on the right-hand side. So when you multiply it on the right-hand side, this basically you're multiplying by FG over 1, and then this is basically by FG over 1 as well. So you just multiply the numerators and denominators by the same, like fraction multiplication works where you just multiply the numerators all on together and the denominators all together. You don't do like this weird crisscross method or whatever. It's just, so FG1 gets brought into this, and then just number one just gets multiplied into the denominator. So you just have FG1 times your universal gravitational constant, which is big G, and then times M1, and then M2, and then all divided by the R squared. Okay. Okay. So I'm gonna put a star because I'm gonna post these lecture notes after on Google Classroom. So what I'll do is I'll put a spotlight here for the completion, and I'll look at it after. So I'll really expect to see this question on your unit test. So if you follow the steps all the way to what I brought you guys to, then you guys should be good. So this is a good practice. Complete the question and then submit it to the or submit it to my email. Oh, I'll put a stamp. Okay. Put a star here. So everywhere you see 3 gold stars is where you have to complete the final solution. Okay, let's go over now another example. So example number 2. So we have this question that says determine the magnitude of the force of attraction between 2 uniform metal determine the magnitude of the force of attraction between 2 uniform metal balls of mass 4.00 kilograms used in a woman's shot putting event. Okay, so, and then we also know that the centers are separated by 45.0 centimeters. Okay, so we're looking for the magnitude of force. Let's just see using the grass method. So I'll use what we're given. Universal gravitational constant's always going to be given. You can ask that on a test, or even when you get to university, like all of these constants, if you just don't remember them through enough practice or whatever, like you can just ask any TA, like or professor, like they'll give it to you. It's something you don't need to memorize, but over time, I guess you just will see, okay, big G is 6.67 times 10 to the negative 11. Like that's just straight. And then the others, like gravity is like minus 9.8 meters per second squared. Like, anyways, so M1 is equal to M2 because they're the same mass. So we know that's being 4 kilograms. The radius, it's in centimeters, always convert it back to meters. So 45 centimeters is equal to 0.45 meters. And then what we're required to find is the force of gravity on object 2 onto 1. So, right, so this question, did I go off the page? Oh, no. Okay. Okay, this question, okay, so let's see. Okay. Okay, so I'm gonna give you guys 5 minutes to independently work on this question, and then I want to reconvene at 1:55 for the final answer. So this will be in class participation. I got everyone's attendance. So everyone that's here is good for attendance. This will be just in class participation. So I'm not looking for the right answer. I'm just looking for whatever solution you can generate. So from what I presented in our given and required section, so it's okay. I'll provide this. I guess I can provide the formula as well for the method to solve it. So we have force of gravity is equal to big G times M1 times M2 all over R squared. And then, right, so just see if you can plug in the numbers and then generate the solution. I will provide the solution at the end of we'll reconvene 150, what's it, 150, 158, 159. I'd say 2 o'clock. 2 o'clock we can reconvene. And then, right, so I have a solution ready, and then I'm not marking for right or wrong, I'm just marking for participation here. Okay, I think we're good to post the solution now. So so let's just go with okay, so I got some feedback in the chat, which is good. But so what I was looking for was basically 6.67 times 10 to the what's it, times 10 to the negative 11. I'm not going to include, you don't need to include the like newtons meters squared over kilograms squared. Like that's okay. As long as you include the just include the right numbers. That's it. 4 kilograms times 4, and then I'll draw this line. I don't really like this pen tool is kind of like laggy, so it kind of gets in the way of things. Right, 6.67, then multiply this by 0.540. Yeah, that's good. That's good. Solid. Okay. And 0.540 meters, or no, include units squared. Okay. So that's what should have been the solution. The final answer here, one sec, I'm posting the final answer. Tool is just lagging. Okay, it's equal to yeah, so 5.27 times 10 to the negative 9 newtons. Newtons. So right. So if you got that answer, good. Any other answer, that's okay as well, as long as you understand. Okay, it's probably just a notation thing. I think when you're inputting in the calculator, it has to be negative 11. So make sure it's negative 11. You should be good. So, okay, let's go with example number 3 now. So, okay, so okay, so what we have here is this question that says, what is the magnitude of the force of gravitation? Yeah, I think I spelled that right. Yeah, gravitation. Yeah, attraction between 1.8 times 10 to the negative 8 kilogram special oil tanks with their centers when 4 meters apart. Okay, so this question basically says that you have these two oil tankers separated by some distance. What is their force of attraction between the two objects? Now, one thing you should, I think, just keep in mind when you're looking at these questions is that you're going to see like really big numbers. Like 1.8 times 10 to the 8 kilograms is absolutely massive. Like that's actually huge. Sorry, 10 to the 8 kilograms. And they're separated by some distance, which is 94 meters apart. So it's close to 100 meters. So basically like a tenth of a kilometer apart. Okay. So yeah, so it's pretty straightforward. And like I said before, like all these questions that you're seeing now is basically gonna be what you see on Unit 3 tests. So it's not for anything. Like I'm not just posting these questions for anything. It's more so you can see the same question, same types of questions on the test. So again, using the grasp method, what we're given, state what you're given, state what required. Analysis part is basically like writing out the formula that you're going to use to solve it, and then you just finish off with the solution. and then you paraphrase it. So paraphrase it. I'm not looking for paraphrase. It's not required. I think if you find your solution, you're good. But just at least if you can get through steps 1 through 4, like think of these as steps. Okay, in step number 1, you have to state everything that you're given in the question. In step number 2, you're gonna ask yourself, okay, what does this information tell me? Like, what am I gonna do? In the analysis part, you just basically say, okay, from the required section, I have all this information now in specific forms, like aka variables, and now I just plug it into the formula. And then from the analysis part, you just compute and solve the solution. So we'll reconvene. Actually, let me just see if I can solve this right now. Yeah, so why is this? Why is it lagging? I don't have my mouse. 1 second. Okay, so why is it not working? Okay, 1 second. Okay, okay, 1 second. I think I got my mouse back. Okay, there you go. Okay. Okay, so what we're given in this case, I'll start you guys off and then you guys can solve the rest of it. So, right. So basically, it's standard. Big G is equal to 6.7 times T commas because my pen tool is so G connection table. No, it's fine. Okay, so I'm just gonna separate it by commas. Okay, so M1, M2, I think we know that it's given it's 1.8 times 10 to the 8. Okay, and then obviously our well, I'll just M1 equals 2 equals that. And then R is equal to 94 meters. Okay. What we're required to find is the force. So that's equal to question mark. And then basically the formula, I'll just see if the pen can work this time. Okay, great. So F equals, well, force, so FG, I'll denote that, is equal to big G times M1 times M2 all over R squared. So solution, I'll post the solution. I'm gonna give you guys, is it 2:10 right now? So I'll give you guys 10 minutes. Give you guys 10 minutes, let's see if everyone can get the same answer this time. So again, just post in the chat and you guys should be good. So 2:20, we can reconvene and I'll post the solution, the final answer. And my pen is not working again. Okay, 1 second. Let me just wait. Okay. Okay, so got some answers, which is good. Final answer is 251.65 newtons. So let's see what we can calculate. So hmm, okay. Okay, so we have F is equal to so I'm just gonna not write out the like the actual units, so I'll just put in the numbers. So it's 6.674 uh times 10 to the negative 11. Okay, and then you multiply this by 1.8 times 10 to the 8. Um, okay, and then you do that again, so you have 1.8 times 10 to the 8 squared, or sorry, times 10 to the, yeah, just to the 8. Okay, and then we divide it by 94 meters squared, so, or just 94 squared. Okay, so you should have gotten in the numerator 6.67, 1.8 times 10 to the 8 squared basically is just 3.24 times 10 to the 16. So let me write that out. One's like 6.67, 4. We're going to keep this as is, and just focus on these two components. So we have that one to be 3.24 times 10 to the 16. Okay, and then just as divided by 94 squared is actually 8,836. 8836. Okay, and then right, so multiplying the numerators together, we get 2.2254. Yeah, 2. Oh, my pen's backing up. 1.54 times 10 to the 6. Okay, and then divided by 8,836. Okay, right. So when you input all of this into your calculator, or however, I think you can use Desmos. Desmos is a great tool. Here, I'll just post it in the chat. I really like Desmos scientific calculator. I think it's a great tool. Used it all in my first year, and basically, I still use it actually. So it's pretty really useful. Um, um, right. So the final answer in this case is just 251.65. Okay. Okay. So right. So that was example 3. Okay, so what time is it? 2:26. Okay. So what I have left is, so basically what we're gonna do for the rest of the class is I'm gonna reference the YouTube video here, and I'll link it in the chat because I think I believe it's very helpful. And so one thing about these YouTube videos is that, like, these types of questions that you actually see on YouTube is is very similar to what you'll actually see in first year university. So, and even in your second year too, because all the courses are kind of not the same, but like they're very textbook driven questions. So like I like the best way you can get through those first year and second year classes is basically grinding out as many different questions as you can manage. So um one second, where is it? Shoot. Okay, right. Right, so okay. One second, I'm gonna share my screen. Okay, so right, so the rest of the class is gonna be basically like I think around 20 minutes, 20-minute YouTube video. It's not too long.